My name is Jacob McBride. I'm the accumulator lead for the Missouri University of Science and Technology Formula Electric team, Team 242. As you can see here, this is our accumulator. First off, we have high voltage always energized with the symbol visible from all angles of the battery. Here. All right, so in the battery housing, we have 3 different PCBs. This is our fault controller. It's a completely isolated GLV board. It works with our battery management system. This is our HVI over here. It is completely isolated high voltage, and this is our voltage tap board. This is in the battery below this lid. It's also completely high voltage, so no spacing requirements are necessary on any of these boards. This is a part of one of our modules. We use Energous 6P packs with patch bolts going into their blind OEM holes to bolt them into each one of these Teflon plates. And then we use copper bus bars to connect the modules in series like this. The Teflon provides structure to the modules as well as electrical insulation between this and the top of the housing. Also, there's no solder in this high voltage path right here. Now in the lid, as you can see, all of these low voltage lines are insulated with rated heat shrink, and there's no solder in this high voltage path, or in any of these. So as you can see in here, all of our low volt connections are heat shrunk down here as well. This is our Orion thermistor expansion connector. This is our fan power connector. And then moving over here, and this is our main I/O harness for our Orion, which is also heat shrunk. Moving over here, we have all of our safety disconnects. They are bolted into bus bars, which are bolted into each of the modules. There's distorted nuts used on the bottom of these, so they are positively locked, making the whole high current path positively locked, as well as no solder in the high current path. Our housing is made of aluminum, so to isolate against that, we have one layer of Nomex 410 paper all along the inside, covered with Kapton tape on top of that for electrical insulation. This is true for all 4 modules, as well as everywhere else inside the housing. Coming over to our lid, we also have Nomex and Kapton. We also have our 80 amp fuse in the high current path, which is our main fuse. You can also see that we have no always energized tractive system wires outside the housing because they are connected to the opposite sides of these contactors, which are normally open, so there's no way for tractive system power to be outside the housing unless these are turned on. Additionally, we have all of our branch circuits fused with 500 milliamp fuses rated for 600 volts DC, which our battery is 336 volts max, so that's well within range. One of our HVI wires is fused here. The other one is not because it is less than 150 millimeters long. Both of our pre-charge wires are fused because they are both longer than 150 millimeters. Once we've unbolted the lid, take it off. The battery is fully connected and energized right now. Before any other wiring is touched, we can remove each of the service connectors without any additional tools to step the battery voltage down into 4 sets of 84 volts instead of the total 336. Once we have that, you can see that each of these bus bars is non-conductive where they stick out of the connectors, and then also it cannot be installed incorrectly to short any of the modules together in an improper fashion, and obviously these can't reach across. Each of our 4 battery modules is separated by an electrically insulative and fireproof material. There is an aluminum wall which is coated again in Nomex 410 and also Kapton tape, which is electrically insulative and fire resistant. And then the bottom of the lid over here, this is the top of this lid would go on top of these right here. You can see it's also covered in Nomex and Kapton, so it completely separates each module from the next module. As you can see, the only tractive system connector leaving the accumulator housing is this guy, which has an interlock right there that prevents high voltage being present if it is not connected. So here we have our MSD, which connects to our charger. It's the same one as before, so it still has that interlock on it. The high voltage charging leads are still orange, and it is still fused because it's connected to the same circuitry. So what we'll do here is we'll plug this into our charger over here. This is our tractive system measuring point. Take this little cover off. We have our HV positive and HV negative here. They are red shrouded banana jacks, both of them. We can plug this multimeter into these guys like so. All right, now you can see we have 0 volts across this point, and the HVI is off. Now, when we turn the low volt system on, the HVI does not come on because the contactors have not closed and we're not charging yet. Now what we'll do is we'll flip the charger on, and that contactor should close and the HVI should come on once we get above 60 volts on this multimeter. Do that, immediately at 329 volts, and the HVI is on. You can hear the fans come on the charger. Now we'll stop the charger, and once that goes below 60 volts, which it did, the HVI goes off, and there's no voltage outside the housing anymore. Also, we have nylon patch bolts going on into each of these blind OEM holes on our main contactors for our positive locking in the high current path, as well as lock washers on our relay. Coming over to our charger, we also have positive patch bolts for our MSD and also lock washers on the relay.